Welcome to Brain Vision.
So we need to calculate the speed and the maximum amplitude. So this system is undergoing simple harmonic motion, and we can say that the mass is going to be equal to 2.7 kilograms. We have a spring constant of 310 newtons per meter, and then we have a compression, or rather just a spring displacement of 0.020 meters, and a velocity of 0.55 meters per second. So we can say that energy total for part A, energy total equals 1/2 mv squared, so the potential energy, plus 1/2 kx squared, and this is going to be equal to 1/2 k a squared. So this is instants, essentially. When the spring is compressed 0.020 meters, the object, the mass, is going 0.55 meters per second, and this is all going to equal the maximum potential energy of a spring, which would be 1/2 times the spring constant times the maximum amplitude squared. So we can say that the amplitude is going to be equal to the square root of mv squared divided by k plus x squared. And solving for this, we can say that m, so 2.7, 0.55 squared. This will be divided by the spring constant of 310, and then plus 0.02 squared. And we have that the amplitude is going to be 0.055 meters. Now it's saying what is its maximum velocity after the spring is fully decompressed, essentially. So we can say that for part B, the total potential energy of the spring is going to be equal to 1/2 mv squared. So in this instance, all the maximum potential energy of a spring is all being converted into kinetic energy. And then at this point, we can just solve for the velocity and say that this is going to be equal to the amplitude times the square root of the spring constant divided by the mass. And we can say this can be equal to 0.055 times the square root of 310 divided by the mass of 2.7, and the velocity is going to be 0.590 meters per second. So this will be our final answer. That is the end of the solution. Thank you for watching.